Hi, and welcome back. Today we're going to cover Module 8, where we're going to look over common metals that are used in mechanical component design in mechanical engineering. This is still part of Unit 1, Material Properties and Design. So the learning outcomes for this module are to understand why this course focuses on metals, and then become familiar with the properties of common engineering metals. So this course focuses on machine elements, and specifically in parts 2 and 3 in this course, we're going to focus on the analysis and design of specific machine elements such as gears, bearings, shafts, fasteners, and springs. These components are used across a variety of industries, including agricultural, aerospace, automotive, oil and gas, and maritime. And when you look at the machine elements such as gears or shafts throughout these industries, they're almost predominantly metal. That's because designers have looked at the material considerations. Most of these industries, the design applications require high loads, they need high strength materials, they require long lives, there's a lot of wear. Some of the operating environments, especially in the aerospace, the maritime, and the agricultural industries, can be quite difficult, from the corrosive seawater environment to the difficult launch environment for space. And then many of these operating environments have high safety considerations due to the number of humans working around these machines. So primarily metals compose these machine elements, and that's why we're going to focus on metals in this course. Specifically, throughout this course, what we'll see is a lot of steel, aluminum, and titanium. Now, steel and aluminum are probably the most common metals used in engineering materials. And titanium is garnered a little bit more attention in the past decade or so. So let's take a look at the positive and negative attributes of both or all of these metals today. So steel. Steel, as a reminder, it's probably been a while since you've taken material science. Steel is an iron, and it's been alloyed with a small percentage of carbon and other materials, including chromium or manganese. Steel is known for its strength. It has a very high strength, and it also has a high modulus of elasticity, which is why you tend to see it in designs that have either high load requirements or that have small deflection requirements. Steel also has a high hardness. It can withstand high temperature. The downside is that it's quite heavy. And then the other nice thing about steel is that you can alloy it with a variety of elements, and that gives you control over if it's corrosion resistant, how easy it is to machine, and how ductile the steel is. So you really can get a lot of different material properties out of steel just by changing your alloying elements. So the next common material used in engineering is aluminum. Aluminum is known for its strength-to-weight ratio. It's corrosion resistant. It has high thermal and electrical conductivities, and it's very easy to manufacture, especially in machining and casting. The downsides for aluminum are, A, it's not easy to weld. In certain welding, it's not compatible with certain types of welding, and it's not as strong as steel or titanium. So titanium, typically in aerospace applications, when we're using titanium, we're looking for high temperature strength. So titanium is really utilized in operating environments where you're going to see very high temperatures. It's also known for its strength-to-weight ratio. It's corrosion resistant, and it's very, very common in the biomedical industry because it's biocompatible. The downside to titanium is that it's quite expensive, and it can be very difficult to machine. So let's take a look at how these metals break down when we look at a car. So steel is really common in the automotive industry. In fact, something like 12% of steel goes to, or 12% of global steel goes to automotive applications. So when we look at a car, we would see that the input and output shafts in the transmission, those are made of steel. The gears in the transmission, also made of steel. The chassis is made of steel. Some of the structure and panels will be made of steel. The axles will be made of steel. The fasteners, and by that I mean the bolts and the screws throughout the car, will be made of steel. Most of the engine is going to be made out of steel, and a lot of the exhaust will be made out of steel. So it's a dominant metal in the automotive industry. However, aluminum is starting to become more dominant, especially due to some various countries putting pretty strict environmental standards on the automotive companies, and that requires the automotive companies to lower the weight to get better fuel efficiency. So in most cars we see aluminum housings, so the transmission housing might be made out of aluminum, and that's because it's so easy to cast. In some cars we're starting to see aluminum in the body panels and in some structure. This year, 2016, Ford released F-150 that has a lot more aluminum in it, and that was one of the reasons they were able to cut the weight by almost 700 pounds. So titanium is not very common in the automotive industry. You may see it in the very, very high-end cars. So for example, the Porsche 911 actually has a high-end exhaust system that can be made out of titanium. But predominantly aluminum and steel are what you see. All right, so in automotive steels, let's take a deeper dive in how steels are used in automotive industry. So because the automotive industry is such a big customer for steel companies, some steel companies will use up to 30% of their R&D budgets just developing solutions for automotive companies. So it's quite complicated, the trade-offs between steel and aluminum in the automotive world. And keep in mind that while aluminum is lighter, if you can make the steel stronger, you can use less of it. So the strength-to-weight ratio is very dependent on the types of aluminum and the types of steel. But looking at steels in the automotive industry, typically you'll see mild steels used in cars where you need parts that are easy to form. So in the body panels, for example, these will typically be made of mild steels for formability. There's specific types of steels called advanced high-strength steel, or AHSS steel, and in these steels, the strengths can exceed 500 megapascals and can even get into the low gigapascals. So these very specialized steels are utilized in the automotive industry. For example, dual-phase steel are steels that are developed to absorb high amounts of energy. So they have incredibly high energy absorptions, and they're used in the crumple zones of automobiles, where press-hardened steels called PHS steels have very high strengths. And so you'll see these used in the passenger safety cell or in the safety cage. So you'd see them in these regions in the car, where you need to create this safe space for passengers in a crash. You see these very high-strength steels used to promote safety. All right, so that's how the materials that we've covered fit into the automotive industry. Next time we'll get into the nomenclature of various steels and aluminums, and I'll see you next time.